So now we are seeing LCS top down DP. So this is the thing where we are not doing any recursion part plus table that we have seen in memoization. Now we are only doing the table part. Why we are doing this? That's the main question. Why we need it? Why we should not do recursive calls? So let's take a stack and in the stack recursion stored function n, then function n minus 1. Like this stacks become full, at that time stack overflow will happen. So that's why we don't want to go on this situation, and therefore we only do the table. So how, what, in the previous video we see how we make the table, also the recursive call. Now our only thing is the table. So some code variation we will do to make the table. So m and n are changing, so the table will be of m and n. The length of string x, here it is m, and length of y is n. So this will be the table of row and column. Okay, now this is the string x of each row, and this is the column representing n equal to 0. So what is the, so in the recursive code we have seen the base condition. If m equal to 0 and n equal to 0, then it will return 0. So this base condition we will write in the top down approach. In the top down approach we follow a loop. So from 0 to that 0, from 0 to the last one, that is 4, we have to put all zeros here. We have, and from 0 to the last 0th column, last row, we have to put all 0. So these all things will be 0, that I am showing after I am explaining this, and then I will show it. So that's why we in the base condition we will write that code. So first of all we are taking a b e f as a string x and a b c d a f as a string y, and m equal to 4 and n equal to 6. These are the length of the string. So we arrange this x and m here. So in this figure we are representing the smallest sub problems that can be that can occur while doing it. So in m equal to x equal to m 0 1 2 3 and y equal to 0 1 2 means in this particular the sub problem may occur a b e f and ab. Okay, 0 1 2 means less than 2, so a and b, and a b e f, so 3 0 1 2 3. Okay, and therefore it will return the length of the LCS and store it in here. Like this many sub problem may occur. So can you say when the sub problem that occur that consider the whole string at the end? So we have to do go through the end. So if I take t of m and n, then it will not go to the end, because in this area t of 6 and 4 means it is doing -1, so we are not getting this. So if I take t and m and n 4 and 6, so we are not getting this box, and we will get another box, that is this. So we will make the loop, make the length m plus 1 and n plus 1 for this, so we can get this box. And by doing this it will consider the whole string a b e f and a b c d a f. Now after dividing the into smaller sub problems, now at last we return this box. We return this box t of length of x and length of n, will return this box. Okay, to get the length of the longest common subsequence. Now about the function, recursion function, that is function, base condition and choice diagram. So these are, I am telling that these all are zeros and these will all zero because of the base condition, and this part represent the choice diagram. So in the choice diagram we saw in the recursive code that x of m minus 1, when both of the strings are matched, then we will add 1 and that whole part as a LCS, and then if both of the string character are not matching, so we will make a maximum of the LCS part. So x of m minus 1 equal to y of n minus 1. So we are checking this, and then we will 1 plus t of m minus 1 n minus 1. So how this will happen? So t of m on n equal to 1 plus t of m minus 1 n minus 1, and return the maximum t m n minus 1 comma m minus 1 comma n. Just the code variation, we deduct the LCS and write here t m n minus 1 and m minus 1 n, because we are considering the matrix. So that's why we at that location it will store the value. Okay, so that's why we are returning it. So the so at that code variation, we first write the base condition from 0 to m and 0 to n, and then t of m on n equal to 0. These all blocks will be 0. That is the base condition, it's done. Now the code variation part, that is choice diagram part, we will write this code. For I equal to 1, I less than m plus 1. For j equal to 1, j less than n plus 1. From 1 we are starting it because 0 has already been done. So in this position we are starting it. So now in place of m we put y, and in place of n we put j. Okay, by doing so we have written this, and considering it, we in place of it we are pouring something else. If I equal to 0 and j equal to 0, t of I j equal to 0 as per the promise, and from x I minus 1 equal to j minus 1, in place of m it is I, in place of n it is j, and t of I j equal to 1 plus t of I minus 1 j minus 1. Then we have to store the t of I j equal to maximum of t of I j minus 1 and t of j minus 1 comma I. So we will get the longest common substring part, and we have to return the last block, that is t of m and n. So by summing up, we are getting LCS of two string. We are getting the recursion. What can happen? Base condition and call for smaller input, then choice diagram. Okay, in recursive code, in memorization, recursive code plus table we have to do with bottom up approach, and in the top down approach we have seen that base condition we initialize it to 0, and then in choice diagram after it is taking from 1, and in this memorization code we are just doing t of means we are just storing it in the matrix t of m and n. Okay, in that recursion part. Okay, so return t and m, that is the last block we are returning. Okay, that's the code for longest common subsequence.